Today we will be solving the problem called longest subsequence with the decreasing adjacent differences. In this problem we have given an array of integers nums, and our task is to find the longest subsequent sequence of nums such that the absolute difference between consecutive elements form a non-increasing sequence of integers. So in other words, for a sequence like a sequence of 0, sequence of 1, sequence of 2, to till sequence of m of nums, so the difference between sequence of 1 minus sequence of 0 should be greater than or equals to the difference between the sequence 2 and sequence 1, and so on. And we have to return the length of such a subsequence. So what is a subsequence? A subsequence is an non-empty array that can be derived from another array by deleting some or no elements without changing the order of the remaining elements. Okay. So if we just look into the first example, so nums is given as 16, 6 and 3. So if we have taken the 16, 6 and 3, then absolute difference between these elements are 16 and 6 is 10 and 6 and 3 is 3. So it is in non-increasing order. So we have to find out the length of longest subsequence. Okay. So how we can solve it? So if you just observe the question, you will try all possible ways. So you will try to get the answer by all possible ways, and you will try to optimize it using DP. And you will get some kind of transition states like this. In this we have taken the index, the previous num and the differences. But if we just look into the constraint, so the nums of length is 10 to the power 4 and nums of I is lesser than or equals to 300. Okay. So if we just compute the time complexity for this, it was about 10 to the power 4 into 300 into 300. That is about to giving DLE. So how we can optimize it? So if we just look, we don't need the previous num. Okay. So what we can do is we can use some kind of these things. In this we have taken the index and difference as the states, and for the transition we are going all the indexes and try to find the absolute difference, and if the absolute difference is smaller than or equals to differences, then we are just finding the answer. But here also if you just compute the time complexity, it is n into differences, that is n square into m, where m is the maximum number of element. So that is also giving us a TLE. So how we can optimize it? So here if we just look, we are going to all the indexes, but do we need all the indexes? So we need indexes whose difference is lesser than or equals to difference. Okay, so what we can do is we will be using a delta in the range of difference to 0, and we will be doing the computation for next positive index and next negative index. We will be writing some logic to get that in big of 1. Okay, and we will be using delta, and delta will goes up to difference only. So the time complexity for this is n into m into m. That is also giving us a TLE, because 10 to the power 4 into 3 into 10 to the power 2, 3 into 10 to the power 4, which is about 10 to the power 8. So that will also giving us TLE. So how we can optimize it? So if you just look, so delta is starting with difference and it goes from, so delta is going from difference to difference minus 1, then it is going a difference to difference minus 2, difference to difference minus 3, and so on. So what we can do is we can add another state that would be removing the for loop. So what we can do is we can compute it like this. Okay, so that is a maximum. We will be using the next positive index, we will be using the next negative index, and we are having a one more transition which is difference minus 1, and that would be reducing the for loop. Okay, so now we will be looking into the code, how we can compute the next positive index, next negative index, and how these things will be working. Okay, so now let's look into the code. So first we have taken the length of nums, the maximum number of nums. We have taken a dictionary which is seen. We have created a matrix for next negative index and next positive index. After that, we are computing the next negative index and next positive index. Okay, so we are trying from the n-1 to the 0 and computing the next negative and next positive integers. After that, for every I, we will be calling the solve function with the difference as m, which is the maximum number of nums. Okay, and for all of them we will try to get our answer. Okay, so first we will get the next negative index, then we will be getting the next positive index, and we will be checking that the next negative index is not equals to n, the next positive index is not equals to n, and then we are checking the difference is greater than 0 or not. Okay, because if it is not greater than 0, then we won't be going to difference minus 1. After that, we are just computing it and returning the maximum, and here we can just return the max of answer. Okay, so that's it for this question. If you have any doubt in the question, please let me know in the comment section. I will try to resolve it. Thank you.